Hi, this is Luontula. The next step in this tutorial is to implement the actual rotation rules for the Tetris pieces, or Tetrominoes as they are called. And when we earlier implemented this piece class which rotates arbitrary shapes, that should make it easier for us to implement these Tetrominoes. So let's get started on this one, and we need that class, and we have some constants for each of these shapes. And we have, just to make sure that they are, because, well, with the piece it might not have mattered whether they are immutable or not, but here, because we keep these in constant fields, and so that we can easily get access to all of those different shapes in our game, it's important that all these constants stay the same. Otherwise, when we drop pieces, then they might sometimes be in different orientation than when they were dropped last time, and that's not nice. Okay, well, that makes, or that's quite trivial to implement that first test, but later, if we are not careful, we might break that contract. Okay, then let's implement the rotations. It must be T-shaped, so let's see. Like that. And we just need to change the toString to return that. Easy. Then let's see. Let's commit this one first. Then let's see. Now when we rotate it, it should turn around in that way. And now it's not yet rotating, but if we use this one instead, then it should become quite easy. And this can stay an implementation detail, and maybe guess unselect. Okay, now it worked. Okay, rotating right works. Then let's rotate it left. Just that piece, that part. So and then this should pass right away. Yep. Now then, let's see the eye shape. It differs in that way that it has only two different orientations. But let's commit this. Then let's see, rotating right or rotating left, one of those should go work right away. But then this second one, this, you will see, this should fail now. And that's because when it's rotated around this centerpiece, then sometimes it's a bit, sometimes this piece is there and sometimes it's here. So it's not behaving the same way as in the game. So let's see. My idea is that, let's see, I will need to count that how many positions there are and then go back to the original orientation. Let's ignore that for a moment and work on implementing this. And let's see. I think the simplest way would be that here in the constructor I pre-calculate all those orientations. Let's first say that how many orientations this has. And that has 2 orientations. Then oh yeah, it's that one. Okay, that worked out. everything's still passing. We haven't, all the code that we have added is still dead. Now then, I think, well, for the first one we need to initialize ourselves, or no, I think no, we can do it like that. Okay, then now we need to pass that as the parameter. And then let's see how about implementing this. Okay, can be rotated right once. Looks a bit different. Oh yeah, that's because we are not chasing that. And now rotating right works, but rotating left fails, and that's because we are getting an out of bounds thing in here. So I think we can fix it like this. We need to make sure that it's positive, and then it's within the range. Like so, then hoping that this piece is not needed anywhere. No, guess something failed. Oh yeah, it's maybe it was the other method, yes. Okay. Okay, I think that's now working. And I think now Now we should be able to unignore that, and it works. And this should pass right away. Yep. And then let's see, the last one, implementing this should be really quick. I think we already have all the necessary functionality for it. First the shape of it. And then the rotations cannot be rotated right. And now it's rotating because I put the wrong default in there, but just to make sure that our test is working, and now that passes. And then that also passes right away. Okay, and that's it for Tetrominoes. Now we could also add all the other Tetris shapes. We don't need to, let's see where. Let's have a reference. Let's zoom out all the possible blocks. So we have the I shape and the O shape, but then this and this, they are different. So the L and J shape, let's see. So some of these say that, okay, what is the initial orientation now? Okay, well, let's not care about the initial orientation. Then like that. The J like that. Then the S and Z shapes, they have only two different orientations. And I think that's the S shape. And the Z is the other way around. Yeah, I think those are now as they should be. And this is declarative information, so I don't think it would be necessary to write tests for them, unless we are then want to be more specific about that how these go. Like, okay, here it goes more to the right side, this shape, and that one also. But we can think about that one later. Okay, well, thank you for watching and see you next time.